Okay, this is the 2018 AP Calculus AB free response. This is the actual free response test from 2018. I'm going to work numbers 1 and number 2 in this video, and this is a calculator. So you're going to want to have your TI-89 ready to go, and there's going to be a lot of calculator work in this one. Since it's hard on these videos for you to really see what's going on with the calculator, I'm just going to write the instructions on how to do it on the whiteboard, and then I want you to follow along and try to get the answer yourself in your calculator. These two problems are excellent calculator practice. So number 1 says people enter a line for an escalator at a rate modeled by the function r, and so between the times 0 and 300 seconds, it's this nasty equation. But no one gets in line after 300 seconds. So it's 0 after that. So part A says how many people enter the line for the escalator during the time interval 0 to 300. So we're adding up, we're accumulating. And so what you're going to do is integrate. Okay, so that's going to be 0 to 300. And for the AP Calc graders, you don't have to write all that out. You can just put r of t dt. So go ahead and put that in your calculator. Make sure in the window that you get it typed in just like that, to the 3rd power, to the 7th power. And you will get an answer of 270. So part A, not really too difficult. Part B says during the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at t equals 300? Okay, you start out with 20 people in line. And then you add the 270 for the arrivals. Okay, that's how many arrived. And it says in the problem description that people exit at 0.7 persons per second. Okay, so that's going to be 0.7 times 300 seconds. All right, so 20 is the beginning amount, 270 is the arrivals, and 0.7 times 300 will give you the departures. So there's no calculus in this part other than using the answer you got in part A. So you would have 80 people in line at times t equal 300. All right, part C says for t is greater than 300, what's the first time t that there are no people in line for the escalator? Okay, well, there are no arrivals after 300. So you start with 300 seconds, plus you know there's 80 people in line at 300, and 0.7 people leave per second. So that's going to be 414.286 seconds. So great. Again, no calculus. It's just, do you understand the problem? There. All right, part D, I don't think I can fit in this little space on the board, so pause that if you need to, and we'll come back and get part D. All right, part D reads, for the time interval 0 to 300, at what time t is the number of people in line minimum? And to the nearest whole number, find the number of people in line at this time. So what you need to do is take the equation, so you're going to solve in your calculator, so hit the solve function, r of t, and you shouldn't have to type it in again. You should be able to go copy it from your previous sections. Minus 0.7 is equal to 0. Because basically we're looking for the critical numbers. Okay? So r of t, the arrivals, minus 0.7, what times is that equal to 0? So if you solve that in your calculator, you're going to get 2 times 33.013 and 166.575. All right, and then what you want to do is check that. So in order to find whether it's a min or a max, we have to check those critical points, and we also have to check the endpoints. So at t equals 0, we know we have 20. That could be the minimum. At t equals 33.013, we don't know. We're going to figure that out. At 166.575, we don't know. We're going to figure that out. And then at 300, we know from the previous problem, I think we figured that out in part D, or excuse me, part B, that there was 80. So we know that's not going to be it. It's either going to be 0 or these two numbers. So how do we figure out how many people were in line at 33.013 seconds? Well, what you do is 20, that's what we started with, and then we integrate 0 to 33.013 of r of t dt. So you've got how many were there, how many arrived, and then we're going to subtract out 0.7 times 33.013. That's how many people departed. Okay, and if you put that in your calculator, you'll get 3.803 people. We're going to do the same thing for 166.575. 20 plus 0 to 166.575 of r of t dt minus 0.7 times 166.575. That's how many people left during that interval. And you'll get 158.070. So that is your answer. You circle that. This is your justification. All right, so there you go. That's part D, and that completes number 1. All right, pretty good problem, good calculator problem. All right, I'll pause it if you need to. I'm going to erase. We'll go on to number 2. All right, number 2 is a particle moving on the x-axis. This is such a common type of problem, and I really would expect you to get one of these in the 2020 test. All right, so we've got v of t, pretty unattractive equation. 10 times the sine of 0.4t squared over t squared minus t plus 3. And our initial position along the x-axis is -5, and that occurs at t is equal to 0. So we're going to need that information eventually. So part A says find the acceleration at t equals 3. So I am going to give you kind of a shortcut on how to do this. I have shown you how to graph something and then find the derivative and plug in a number. So you could do that. You could graph it, go to F5 and dy dx and do that. I want to show you a different way how to do that. So we know a of 3 is going to be v prime of 3. Right? To get acceleration, you take the derivative of velocity. So you can put this in your calculator if you'll hit F3, okay, for calculus, select number 1, and then you'll get a little D that comes up, and then type in V of t. So you got to type in all of that stuff. Then you got to tell it which variable, t, and then close the parenthesis, and then you're going to use the vertical bar. All right, the vertical bar is right underneath the equal sign here. Okay, so after you close that parenthesis with the t, hit the vertical bar, and then you have to type in, all right, don't just put a 3, you have to type in t is equal to 3. So give that a try in your calculator. Make sure you type in this velocity equation correctly. You have to be careful and use parentheses. But the answer that you will get is negative 2.118. So give that a try. Again, you could also graph this and use the dy dx that we've done before. I think this might be a little faster. So definitely one to study. This is a way to evaluate a derivative at a particular point using the vertical bar on the TI-89. Okay, part B says find the position of the particle at time t equals 3. Well, to get position, you have to integrate the velocity. We know we start at -5. And then we have to integrate the velocity from 0 to 3, because that's when we want to know the position of v of t dt. This will give you the movement from 0 to 3. All right? You've already typed this in, so you can just copy that down. And that's going to be negative 1.760. Okay, so this is really an exercise in typing into your calculator. Part C. Evaluate 0 to 3.5 of v of t dt and 0 to 3.5 of the absolute value of v of t. Okay, so you're going to basically just go in there and change that from a 3 to a 3.5. So pretty quick work. So follow along in your calculator and see if you get 2.844. And for 0 to 3.5 of the absolute value, you will get 3.737. Now remember, to get the absolute value, you have to go to the catalog function, right above z, the catalog function, and ABS is the absolute value. It's basically the very first one. We have to explain what this means. So if you don't do the absolute value, that just gives the displacement. So it gives the displacement of the particle for the time 0 to 3.5. Now, using absolute value, that gives the total distance traveled. For the time. Okay, so this just gives the displacement, which because it goes back and forth, it's not going to be as long as the total distance traveled. Okay, so that takes care of A, B, and C. This is I almost probably could fit D in here, but I won't try that. So pause if you need to. All right, and finally part D says a second particle moves along the x-axis with position given by x sub 2. Second particle of t is t squared minus t. At what time t are the two particles moving with the same velocity? Well, we need to get the velocity equation for this, okay? And remember that velocity is just we take the derivative of position. Well, that's pretty easy. That's just 2t minus 1. And then we want to set those two equations. So I guess this would be a velocity of particle 2. we want to set those two equations equal. So we're just going to go into your calculator, hit the solve function, and have v of t, so that's this big nasty thing here, and you can just copy it from a previous problem, is equal to 2t minus 1. And give the answer that occurs between 0 and 3.5. And that you could also graph both of them and see where they cross. But I think just using the solve function would be easier. And that's going to be t is equal to 1.571. But it's also, again, fine to graph and use the intersection function to see where they intersect. So that takes care of the calculator portion of the actual 2018 free response exam. And we will pick up with number 3 on the next video.